I use Tracker to analyze and follow the constant velocity of an object. I then use Newton's second law to explain and predict the motion of that object. I graph the position versus time of the model's prediction and the observed experimental data. I found that the model accurately predicted the object's actual motion. I observed a marble rolling across the table at what I assumed and judged to be constant speed in the same direction. I recorded this motion using my cell phone. I used Tracker to analyze the marble's position and time to find that it was indeed moving at a constant velocity for the portion of time selected to be reviewed, as shown in the table and the graph. I placed the origin of my coordinate system at the center of the marble's mass and tilted the axes ever so slightly so that the motion of the marble could remain on one path in one direction. I set the marble's path to be in the positive x direction because of how I set up the axes. If I were to flip the axes, the marble's velocity would be in the negative x direction. Flipping the axes flips the slope of the graph. However, flipping the axes would not affect the marble moving at a constant velocity. The velocity would ultimately remain constant. Now on to Newton's second law. Newton's second law is a secret of the universe that explains why the marble is moving at a constant velocity. Newton's second law states that the change in an object's velocity over a change in time is dependent upon the net forces acting upon that object and the object's mass. Here is Newton's second law expressed as an equation. Here it is also expressed as the velocity prediction or update form. Because the net forces acting on the marble sum to zero or are infinitesimal, that expression F net over m delta t becomes zero, ultimately making the final velocity or the predicted velocity the same as the initial velocity. I also utilize the relationship between average velocity and change of position and change over time to update the position of my marble during the experiment and in the model. Now onto VPython. I use Newton's second law to create an iterative predictive model of the marble's motion. I assign the initial conditions necessary for predicting an object's motion by setting the mass of the system equals to that of an average size marble and using Tracker to note the initial position and time observed motion. I also use some of these initial I also use some of this initial information from Tracker to calculate the marble's initial velocity. I also set the time step to be very small compared to the duration of the observed motion so that the model may accurately predict velocity and position. I input the necessary physics into the iterative calculation loop so that the code represents the physics of the real world and the motion being observed. During the duration of the observed motion for each time step, the model updated the marble's velocity using Newton's second law, the object's position using the definition of average velocity, and the time at which all of this is being observed. The net force vector in the calculation loop is set equal to zero in order to mimic the net force on the marbles observed in the video. It is not possible for me to say how many pushes and pulls are added together to get the net force of zero because Newton's second law doesn't quantify how many forces are actually acting on a system. Newton's second law only takes into account the sum of all the forces, no matter how many forces there are acting on a system. Newton's second law will help me figure out what will happen to that object's motion depending on the sum of the forces acting on the system. Now on to the results. I plotted the predicted motion of the model on a graph. The predicted motion is represented by a red line. I also plotted the recorded motion on the same graph. It is represented by blue dots. As seen here, the model is almost an exact prediction of the object's motion. This indicates that the model is an accurate indicator of what happened in the observed motion, all as a result of accurately using Newton's second law of motion. The extremely slight variation between the model and observed motion may be due to an error in accurately tracking the position of the marble in Tracker. At certain points in tracking the motion, the marble was blurry and it was difficult to precisely identify its center of mass. Regardless, the model is still an accurate predictor of motion.